What's going on, you 3D modeling beasts? This is JL Musi, and welcome to part 3 of creating stylized environmental art using Maya, ZBrush, and Substance Painter. This series will document my entire process of how you can take any reference, any object, and turn it into a stylized piece of art that is ready to throw into a game engine. This series is sponsored by Autodesk, and in this third installment, I will break down step by step how to create stylized details into your high poly sculpt, all within ZBrush. If you want to follow along and download my project files, which include the blueprints that I specifically created for this project, you can click the link down below and it will walk you through the process of getting those files. If you've missed the previous video on how to create a blockout quickly and effectively in Maya, you can go ahead and catch it by clicking this card here, and that way you'll be able to access that video before moving forward. If you get any value from this video, I would greatly appreciate if you could smash the like button, as it does help the channel grow tremendously. So the very first step in ZBrush is to import that high poly FBX that we created from Maya to start sculpting our additional details into our high poly. And for this, we're gonna use a nifty Z plugin called the FBX importer. This is a true lifesaver, especially if you used to do this the old school way like I used to do, where I would export a bunch of OBJs and have to individually import them and then append them. So this is a quicker way of just getting multiple objects into one scene into ZBrush so you can quickly start sculpting. Once I have my model properly imported into ZBrush, what I like to do is do a overall scan, make sure there are no holes in my geometry. Most likely, as I mentioned in that blockout video, if you have any n-gons, a lot of times ZBrush will try to fix them, but it can lead to missing faces. So if you have any gaping holes right when you import your geometry, you can just go back into Maya, look for any of those n-gons, fix them, and then simply re-import your mesh. Before I break down my sculpting workflow within ZBrush, I do want to explain why I actually prefer to do some type of details, especially normal map details. At the end of the day, that's essentially what you're creating. You're creating a mesh that we're gonna essentially extract those normal map details from this high poly mesh and actually bake them out. You do have the ability to create normal map information as well within Substance Painter. So let's go ahead and take a look at some of the advantages of creating some of this normal map details within ZBrush versus Substance Painter. And like I said, this is all pretty much my opinion. Everybody's gonna have their own preferences. First on my list is that you actually don't need UVs to create essentially high poly details. ZBrush actually relies on polygons, or as they call pixel information. And by us subdividing these meshes, we really don't need to have a proper UV layout to start carving in secondary and tertiary details. Another reason I like to use ZBrush at this part of the process is that it allows you to break silhouette. So sometimes coming right off the blockout stage, you might have to hammer in some details that need to break that silhouette. And as ZBrush is polygon dependent, you could actually do so versus using a package like Substance Painter. And lastly, I do like ZBrush for breaking up edges. And we established earlier that breaking up those edges and having very distinct edges that vary in edge width is one of those stylized characteristics. So ZBrush really lends itself well, as a lot of times you are pretty much deviating slightly from the silhouette. And also it allows you to sculpt wrinkles. In my opinion, some of the brushes are a little bit stronger for sculpting wrinkles. And that's why I choose to sculpt the wrinkles on the bench pad with ZBrush rather than do it within Substance Painter. The next step here is to subdivide our mesh. As we stated earlier, ZBrush is pretty much polygon dependent or pixel dependent. And the more pixels that you have, the more detail that you will have in your sculpt. There's two methods that I'm going to use here to add more resolution to my mesh, and that is the subdivide and the Dynamesh method. Let's go ahead and take a look at the subdivide method first. In areas where I want to preserve that curvature, I will use the subdivide method. When we're doing the subdivide method, just like in Maya, when we hit 3 mode and go into sub-D mode, we will need some holding edges. These holding edges could either be done in Maya or they can be done in ZBrush. I'm actually going to do them in ZBrush, but there's really, in essence, no difference. I am using the Zmodeler, and right off the back with the Zmodeler loaded, it will let you add essentially any holding edge by simply clicking the tool where you need that holding edge. One of the added benefits of using the subdivision method versus maybe the Dynamesh method is that it lets you progressively subdivide your model. So you could actually go back through different levels of density in the subdivision and sculpt different type of details. And this is great for progressively building out your details, because some details, especially some of the secondary shapes, are better off sculpted in a lower subdivision. And then some of the very fine or tertiary details are obviously better suited sculpted in a higher subdivision. In this example, you'll see me add holding edges and then subdivide this plate, because if I was to run Dynamesh, even though it would give me the proper number of density in order to sculpt detail, it would actually preserve those stepped edges from my cylindrical base. And the problem with that is when we go to bake or normal maps, those stepped edges are actually going to show up. So it's not going to really smooth that curved surface like the subdivide method will. And the second method for adding more resolution to our mesh is the Dynamesh method. Now, the advantages of the Dynamesh method is that we don't have to worry about holding edges. It's going to do a pretty good job of dividing everything. Like I said, the only caveat to this is that any curved surfaces will pretty much not be smooth at all and will inherit the original smoothness from our low poly mesh. Areas that are great candidates for the Dynamesh method are pretty much any areas that are primarily flat. So you see that most of this bench, most of these support beams are primarily flat with some bevels. And in this case, it saves me the trouble of having to add holding edges, whether I do it in Maya or in ZBrush, and I can skip that step altogether. Now, one of the things you do have to keep in mind when using Dynamesh, it can be a little bit more destructive. So you really have to play around with the settings. And there is some additional prep work that you might have to do. For example, for these letters, you'll see me actually split everything into different polygroups. And what this will allow you to do is actually enable the polygroups feature within the Dynamesh settings. A lot of times when objects are really close together, Dynamesh has a habit of actually starting to merge shapes, and that's the last thing that you want to do. It is a little bit of prep work. You might have to play with some of these settings, also the resolution, and that little circle there in ZBrush, and this is pretty much a global setting that you'll find in a lot of the menus. It actually changes the way that ZBrush solves for certain operations. So enabling that can get a different solve in the way that Dynamesh works, and it could give you a better result. And the very last point here, and I can't stress this enough, is that it's very important not to confuse Dynamesh with Dynamesh. Get it? It's a dinosaur made out of the polygon, so it's a mesh. Dynamesh kind of sounds like, you know, Dynamesh. What? Content creator and 3D artist JL Musey makes 3D jokes so bad, YouTube decides to bring this like button back. Uh-oh. Oh boy. Guess that's one bad 3D joke too many. It's time for this ninja to vanish. Before I start breaking down my actual sculpting workflow, I do want to mention some of the brushes that I use and that you'll need to actually download in order to follow along. So the first set of brushes are pretty much the default brushes that ZBrush ship with. The second one is actually a set more catered specifically to creating stylized sculptural details. And this second set comes from a Blizzard artist named Michael Vicente. Very talented artist, has been doing stylized art for a very long time. So I'll actually have a download link to his Gumroad page. And while these brushes are completely free to download, I strongly do recommend that if you're financially able to do so, just give him a little bit of a tip. I know he'll greatly appreciate it. He's really done a great solid for the 3D artist community by releasing this set of brushes and having pretty much any artist that wants to create stylized art be able to use them. I've broken down my sculpting into 3 stages. These 3 stages pretty much apply to everything but the actual leather pads, which I will discuss towards the end of the video. The first pass here is to break up my edges. This is pretty much the longest part of the workflow, as I pretty much tackle every single edge that is beveled, which is pretty much my whole mesh. So what I'll do here is first start off with the Trim Dynamic brush. And what the Trim Dynamic brush allows me to do is really just change the shape of those edges and really just vary the width. And this is gonna give me pretty much the basis for that stylized edge look that I mentioned earlier that is so important to getting this look right. After I did my initial round of breaking up these edges, I'll come in with the Orb Flatten brush. And what this allows me to do is actually get multiple angles and different little shapes from that initial pass that I did with the Trim Dynamic. So you see, by using the Orb Flatten brush, we started to get all these different nice angles, and it really starts to break up the edges and give them that nice stylized look. The next part of this is adding damage. And for this, I use the Orb Slash, usually 1 through 3. And I also will use the Orb clay tubes to break up my surfaces. What I try to do with the Orb Slash brushes is use them very sparingly because they are pretty significant in size depending on how you drag this out with your alpha. But you definitely don't want to go too heavy-handed on this. You don't want to repeat these too much. And you also want to add some variety by using the different variations that Michael has provided within his brush pack. Lastly, you will see me add very sparingly to certain parts like the dumbbells, some actual tertiary or noise detail to my dumbbells here. And for this, I am using the Orb Rock Noise 3 to actually just layer on some of this detail onto the dumbbells. Anytime that I'm adding this tertiary or noise type of detail across large areas of a mesh, I do tend to use sculpting layers. Sculpting layers do give you the ability to sculpt on a layer, and if you don't like that detail or you went too heavy-handed, you have the ability to increase, decrease, or even delete that layer altogether. Once I added all those stylized sculptural details that I wanted on my hard surface parts, I'm gonna break down my workflow for creating the wrinkles and the details within those bench pads. First thing that I set out to do is actually create those panel lines within the actual different strips of leather that make up pretty much the bench pads. For this, I actually did opt to use the Topology versus actually carving in these with a brush. What this allows me to do, especially if I have a relatively clean base, I can leverage the power of Zmodeler and really the power of relatively clean topology to create panel lines. The next task in creating these panel lines using the Zmodeler brush is to actually break up every single panel into its own different polygroup. And even though these 2 polygroups here on the top looks like one solid shade of green, it's actually 2. Not sure if that actually comes across in the screen recording. With every single panel here broken up into its own polygroup, I can go in the Zmodeler brush, enable the inset option, and also enable the target to be a polygroup island. What this will allow me to do is actually inset each panel, and leaving behind, I have a clean panel line. With that clean panel line all within one polygroup, I can use the cube mesh function within the Zmodeler brush and actually extrude down. The last thing that I want to do here is add any reinforcing holding edges, because once I start subdividing, very similar to how you subdivide in Maya, if certain corners or certain shapes are not properly reinforced, you're going to lose a good chunk of that shape. So now if I fully subdivide this mesh here, you'll see that we have these very crisp panel lines that were done using that existing clean topology. And that's why, even though we're sculpting in ZBrush, sometimes it does pay dividends to have a relatively clean mesh. That way you can extract or create certain panel details using the topology versus trying to sculpt them by hand. Now that the panel lines are out of the way, I'm going to use some of the native standard sculpting brushes that ZBrush has to offer. I'll go through using the standard brush. I'll start carving out the bulk of the wrinkles. Also will use the clay buildup brush. By default, when you use that square alpha, it can seem very clunky at times. And that's why if you actually choose a round alpha from within that brush, you'll get a much softer stroke. It lends itself pretty well to create these wrinkle type details. Once I have the bulk of those wrinkle details carved in, you will see me use the dam standard to add extra definition between those wrinkles. The last part of the workflow that I want to break down here is symmetrical details. Always keep this in mind that the high poly here is basically just going to be used to extract a normal map. In essence, this is a texturing workflow. If my production requirements allow, meaning that I have bigger texture sizes to work with, I actually opt not to have texture detail being mirrored along the symmetry line. What tends to happen is if you're maybe to add a very specific damage, like a slash, right along a symmetry line, and you have that mirrored over, that texture detail is actually very easily noticed that it's being repeated. That can actually just throw off the uniqueness of the model. So what I tend to do is I do try to take advantage of overlapping UVs, but I actually opt to have this texture detail that is being repeated in areas of the model where the viewer can actually see both sides of the model. So even though the texture detail is being repeated, it's not going to be in the detriment of the visual quality, and you're not going to be seeing a repeatable pattern versus if you were to add that symmetrical texture detail at the very symmetry line of your model. So once I figured out what details are actually going to be mirrored over or not, any detail or any parts that are going to contain mirrored detail on the other side, I can clearly delete those, as the stacked or mirrored UVs are actually going to take care of that mirroring, and I don't necessarily need those in my high poly mesh. That is pretty much the bulk of my high poly stylized sculpting workflow within ZBrush. So before exporting this into Substance Painter for baking purposes and into Maya for retopology purposes, we have to bring down the poly count. Outside of ZBrush, which is very well equipped to handling millions of polygons at one time, most 3D packages are not. So for that reason, we need to lower the poly count, but in essence, preserve most of the details. And this can be achieved with a process called decimation. This process can be correlated to what web developers do in order to upload large images onto a website. Is what they'll do is they'll take an image in a native format and they'll actually export it as a JPEG, but they'll optimize that JPEG to keep most of that image quality there while bringing down that file size. And decimation is a very similar process. The decimation master can be found under Z plugin, and each piece needs to be pre-processed before completing the decimation process altogether. What you ultimately want to do when going through the decimation process is you want to lower the poly count as much as possible while preserving the most amount of detail. When we retopologize, we're going to be taking that into Maya. One thing to keep in mind is that you could actually further reduce the poly count of your mesh at this point to have essentially two versions. One for the bakes and two for the retopology. And the reason that we can further reduce our mesh for retopology is that we actually don't really need tertiary details to be able to retopologize. We only need those primary and secondary shapes. And that's a good option to have, is a higher density mesh that preserves all the details strictly for baking purposes, but then having a more reduced file that's going to allow you to take that file and be able to retopologize on top of without your system lagging much. So with the very same FBX importer, we can go ahead and export. Thank you so much for tuning in to installment number 3 of Creating Stylized Environmental Art with Maya, ZBrush, and Substance Painter. If you got any value from this video, please smash the like button, subscribe to the channel to receive more videos like this. And in the comment section down below, let me know of any cool sculpting tricks that you guys have for creating your own stylized art. Until we meet again, folks, I will catch you next time.